that. So what I want to look at now is I want to start looking at measures of spread. Measures of spread, now remember, that's talking about how wide that curve is. Oops, that one's not very good. So we've got the blue curve and purple curve. They both have approximately the same center right here, but the purple one's obviously wider, more spread out. The textbook, I believe, sometimes calls this dispersion, by the way. So how do we describe the spread of the data? There are a few different numbers that we can use to describe the spread. One of them is the range. Range is really simple. Just like we had the mid-range for the measures of center, the range is just the largest value, the maximum, minus the smallest value, the minimum. So let's get a set of numbers here. I'm going to put them in order from smallest to largest just to make it easy on us. So let's do 6, 11, 12, 14, and 17. There's my set of numbers. My range is going to be what? 17 minus 6, which is 11. So there's a range of 11. Any questions? Okay. Now the thing is, I can have two data sets that have a range of 11, look very similar, but very different spread. So this here has a range of 11. I'm going to make a new set. What's the range of that set? It's also 11. Very similar. Both go from 6 to 17. But would you say that they're about equally spread out? I would say this one's more spread out. If I were to put these on a number line, like I did that dot plot for my distributions, this one here, I've got 6, 7, 8, 9, 10. I'm going to have a dot at 6, 11, 12, 14, and 17. The bottom one down here, I got dots at 6 and 7, 12, 16, and 17. Those red dots appear to be way more spread out, don't they? So the range is not adequate to distinguish between the spread of similar sets like that. So we have two others that we use. They are the variance and the standard deviation. And I'm not even going to bother to write the formula up here for these. We're going to do it as a 5-step process for the variance, 6-step process for the standard deviation. They're the same process, as the standard deviation goes one step further. So step 1 is to find the mean. We're going to use our top set of numbers up here, which were 6, 11, 12, 14, and 17. So I'm going to find the mean of that set of numbers. 6 plus 11 plus 12 plus 14 plus 17 is what? 60 divided by 5 is 12 is our mean. So that's step 1, find the mean. We found it, it's 12. Step 2, subtract the mean from each number. So we've got 6, 11, 12, and 7, 6, 11, 12, 14, and 17. And we are going to subtract that mean of 12 from each number. What's 6 minus 12? It's negative 6. 11 minus 12. Negative 1. 12 minus 12. 0. 14 minus 12. 2 and 17 minus 12. 5. Now it's meaningless, but at this point we could double check ourselves. If I add these numbers up, they better add to 0. If they don't, we did something wrong. Our mean is usually made a mistake calculating our mean would usually be the problem there. The third step is to square each of those numbers. So we do have to be careful here. When you put these in your calculator, negative 6 squared better be positive 36. Anything squared better be positive. Negative 1 squared would be 1. 0 squared, 0. 2 squared, 4. And 5 squared, 25. Again, make sure these numbers here are all positive. If you put it in your calculator wrong, if you don't use the parentheses, you just put in negative 6 and hit squared, it'll spit out negative 36, and that is not correct. Step 4 is to add them all up. It's called the sum. Find the total. If I add those up, I get, what, 66? So that's step 4. Step 5 is a little more complicated. Step 5 is to divide by n minus 1. Well, n equals, how many numbers are in this list? 5, right? So n minus 1 is 5 minus 1, which is 4. So I'm going to divide by 4 here, which is going to give us 16.5. That number is our variance. That's all the work for one number. You're absolutely correct. There's even more work to go to find the standard deviation. The standard deviation requires step 6. The 6th step is the square root. Square root of 16.5, 4.1. I'm going to round it to 4.1. I probably should have done 4.06. Rule of thumb. So people always ask me about rounding. That's it. That is the standard deviation. Yeah, that was one more. I know, I was trying to scare you a little bit. I'm a math teacher, that means I'm not a math teacher. Rounding rule of thumb. For the mean, one place value past the data. So for this data set, these numbers were to the nearest 1, right? So the mean can be rounded to the nearest 10th. One decimal place. We didn't have to round in that case, so we did. Standard deviation. And the variance will be the same. Is 2 decimal places, 2 place values past the data. That's why I came back and made this 4.06, because our data was to the nearest 1. My standard deviation should be the nearest 100th. 2 place values passed. So let's look at this example here. We had the other set of data, 6, 7, 12, 16, 17. Let's find the variance and standard deviation. What's my first step? Find the mean. So 6 plus 7 is 13, plus 12 is 25, plus 6 is 41, plus 7 is 58 over 5, which is going to give us 11.6. Is that correct? 1 decimal point. 1 decimal place past the data, 11.6. What's step 2? Perfect. Subtract the mean. Got 6, 7, 12, 16, and 17. I'm going to subtract 11.6. 6 minus 11.6 is a negative 5.6. 7 minus 11.6, negative 4.6. 12 minus 11.6, 0.4. 16 minus 11.6 is 4.4. 17 minus 11.6 is 5.4. Step 3, square each other. Negative 5.6 squared. Notice I didn't bother putting the negative in because I know it's going to be positive. 31.36. Negative 4.6 squared. 21.16. 0.4 squared is 0.16. 4.4 squared is 19.36. And 5.4 squared, 9.16. Good. Step 4, add them all up, total them up. Which that's going to add up to what? $101.20. Yes? Okay. Step 5. Divide by n minus 1, which means I'm going to divide by 4, right? Which is going to give us 25.3. I did that correctly. That is our variance. So standard deviation would be, you got it. What's that? 5.02. Good. So that's 5.02 compared to 4.06. So it confirms to us that this set of data is more spread out than the other one.